So we've got a few definitions we have to get through today. Not too terrible. So first one is an angle. We all know what an angle is, just looking at it, you can draw one, but the actual definition is it's formed when two rays share an endpoint. All right, then we have the initial side of our angle. What's the initial anything? Like, what do you think of when you hear initial? The first? Yeah, like where it starts. Yeah, so that's what it is. The initial side is just where your angle begins. So, or where the angle starts. What do you think the terminal side is? Yeah, where it ends. So with our angles, we can have positive angles and we can have negative angles. It all just depends on the direction that your angle is rotating. So positive angle rotates counterclockwise. Let me draw one for you. So this would be my initial side. For what we're doing right now, the initial side is always going to be on that positive x-axis like that. Okay, that's always where you're going to start. And then let's say, here's my terminal side. If I rotate counterclockwise like that, so I started and rotated counterclockwise, that's a positive angle. So what direction do you think a negative angle is going to go? Clockwise, yeah. All right, so drawing one of those, again, our initial side over here on the positive x-axis. Let's say my terminal side ends up down here in the third quadrant, and I rotated that way. So it has nothing to do with where the angle ends, like where the terminal side is. It's all dependent upon the rotation, clockwise, counterclockwise. So standard position of your angle, which is really all you're going to need, two things. The vertex is on the origin. And the initial side is on the positive x-axis. So both of the angles I drew were standard position angles. quadrantal angle. All that means is the terminal side is on an axis. So if your terminal side ends up on the y-axis, the x-axis, the negative y-axis, anything like that, that's a quadrantal angle. So let's go back up, just a quick review of your quadrants. This is the first quadrant. Do you guys remember which direction they go? Those counterclockwise. So that's second, third, and fourth. Absolutely. Squeeze one in over here. So let's say, here's my initial side. Okay, and let's say there's my terminal side, so like a 90-degree angle. That's quadrantal. Because you see how you can't tell me like, oh, that's in the first quadrant or second quadrant? Don't know what quadrant it's in. It's quadrantal. Okay. All right, so let's do a couple of examples here. I'm going to do number 1 with you, and then have you try the other 3. So draw yourself just a little XY axis. So 55 degrees. To draw that, I start with my initial side on that positive x-axis. And then where is 55 degrees? Like how far? Which quadrant do I get to? Yeah, it's in the first, right? Now when you're sketching angles, I do not expect perfection. I'm not going to look at it and go, nope, that was 57 degrees, that's wrong. Like, general area, first quadrant, that's all I'm looking for. So we'll say somewhere in there, okay? And the only other thing you need to do is put a little arrow in showing me, like, hey, I started here, rotated counterclockwise. And that is in the first quadrant. Okay. So I want you guys to try sketching 2, 3, and 4 for me.
That's the arrow. I literally was like, let me just do 4. Yeah. 70. Going in style. Just starts rotating.
Maybe I do like do those. Give it like a double arrow.
The 425.
The last one.
I made sure that it wouldn't overlap the images, so it looks like
Good. Yeah, that's perfect.
I was like, wow.
Yeah, and so you're gonna have like a little spiral. Got it.
I was literally like, wow. Okay.
I mean, there's something delicious like that.
Very good. Sketch. All right, so let's go through them. So negative 180. So I start over here to go backwards, right? And it's just directly across. Hopefully yours is prettier. So throw that little arrow in. Okay, and then I said state the quadrant that it lies in. Is that in quadrant? Quadrantal, good. Quadrantal, yes. All right, 280 degrees. So I start here. Start working around. So here's 90, 180, 270, so just a little past that, right? So what quadrant is that? 4. Good. Throw your little arrow in. 4th quadrant. Okay. All right, 425. Well, it's 360 all the way around, so what do I do? Just keep going. Yeah. So how far past 360 is it? 65, yes. So what quadrant would 65 be? First. So I've got my initial side. I'm going to end up somewhere in here. And then you just show this fun little spiral that I went around. It's pretty. So we feeling okay with this? Okay. All right. A radian. So you guys are very used to angles being measured in degrees, okay? By the end of trig, you will like radians as a way to measure angles better than you like degrees. You won't believe me at first, but you really will, okay? So 1 radian, it is the measure of a central angle whose intercepted arc is the same length as the radius. It's a lot of geometry terms there. Give me a second to jot it down, then I'll explain what this means, okay? All right, first, what's a central angle? Do you know what that means? Remember from your geometry days? you have a circle, it's the angle whose vertex is on the center of the circle. Okay, so it's just coming right from the middle. So if you look at our picture, that'd be just coming from the origin, just what all of our angles are going to do right now. Okay. Then the intercepted arc. You remember that? If I extend both, and you don't have to write this, I'm going to erase it. If I extend both sides of an angle, that is the intercepted arc. Okay, it's like where they meet the circle. All right, then we're talking about the length of that arc being the same as the radius. So I'll show you what that means. So on the circle, you guys agree that that is the radius? That little red piece? Okay. What we're talking about is taking that length. Like you could measure this. This has a length. I'm going to then wrap that length around the circle. So I'm not going to keep it as a straight line. I'm going to curve it on the circle the same distance though. So starting here, and then I wrap around. That looks pretty close, right? So if I connect that angle I just formed, the measure of it, instead of thinking, I don't know, is that 50 degrees? No, that is 1 radian. So measure of this angle, 1 radian. One more thing to show you the radians here. So this length here, this arc, I'm going to use it again. So starting from the end here, I'm going to wrap that length around again. I'm just going to keep going around in circles. So I'd probably have another one. It'd take me about to there. And then if I did another one, it'd take me about to there. So by the time I get back to the x-axis, I've gone 1, 2, 3, and a little. Do you guys know a number that's 3 and a little? Pi. Hello. So going halfway around the circle is the same as pi radians. Okay. So 180 degrees, which is halfway around, is the same as pi radians. Kind of cool, right? That number actually means something. So what if I went all the way around the circle and I kept marking off, I took marks? 2 pi, yeah, so 360 degrees, that's the same as 2 pi. Okay. Okay. Now we're going to use that. Okay. I think it's already crossed out on yours, right? Yeah. Okay. So one more definition, and then we will use the pi and the 180, okay? So last definition here, coterminal angles. These are just angles that have the same initial and terminal side. So angles with the same initial show you what that means. You can probably squeeze it in on the side of your paper here. But let's just think. let's say that angle right there is 30 degrees. Okay? That's if I'm going in a positive direction. What would it be if I went in the negative direction? Yeah, so 30 degrees and negative 330 degrees are coterminal. So it's like two ways to name the same angle. Okay? How do you think I find them? Like if I know 30 degrees, how do you get the negative 330? Subtract 360? Yeah. So 30 minus 360 will give you the negative 330. And guys, the other thing you could do, I'm going to give you another one. 30 degrees and 390 degrees are coterminal. So let's think about that. So 30 degrees right there, right? 390, the exact same spot, but you've gone all the way around. Okay? So how do I get from 30 to 390? Add 360. So on your notes there where it said how do we calculate coterminal angles, you add or subtract 360 degrees. Or if it's in radians, what would we add or subtract? What was the same as 360? 2 pi. So let's look at these one more time. So I had 30 and I had 390. Do you think I could go around again? Yeah, you could just keep adding 360, adding 360. So there's an infinite number of coterminal angles. You could go backwards. You could go backwards a whole nother circle. Okay, so unlimited answers for these. Usually you just find the one that's closest, but you could find others. All right. Okay, so now let's use that whole pi and 180 being the same thing. We are going to be converting back and forth from degrees to radians or from radians to degrees, okay? It's like, remember you converted from like inches to feet or centimeters to meters, all of that stuff. You had a conversion factor that you would multiply by. It's the same thing. Our conversion factor is either going to be pi over 180 or 180 over pi. So if we look at the first set here, we're going to convert from degrees to radians. Do you see how the pi is in the numerator? That's because I want to end up with pi. I want radians as my answer. Okay, so let's do A together. So I would take the 70 and I would multiply it by pi over 180. All you're doing here is reducing a fraction. So you have 70 pi over 180. Well, what can I divide 70 and 180 by? 10. So your answer is just 7 pi over 18. That's it. So you guys try B, C, and D for me. And no calculators on these. You can do it. right, guys, let's see how we did. All right, so 210 when I do times pi over 180. Guys, if you're struggling at all with the reducing, if you're like, gosh, I'm not sure the biggest thing, start simple. Go, okay, I know I can do 10. So you've got 21 pi over 18. You guys see that can reduce again? Okay, divide them both by 3. So really I've got 7 pi over 6. Okay. All right, negative 190 times pi over 180. What'd you guys end up with on this one? Perfect, negative 19 pi over 18. All right, then this one. Times pi over 180. What did you guys end up with? 283. Doesn't it seem like it should do more? It doesn't. And do you guys know the shortcut for checking to see if something's divisible by 3?
No.
Yeah, so you take the sum. So let's say you have the number like 192. 1 plus 9 plus 2 is 12, right? Is 12 divisible by 3? And 192 is divisible by 3. Yeah, they teach you guys some little tricks anymore, so. All right, so we are okay with degrees to radians. Not bad, right? So radians to degrees. This time we're going to multiply by 180 over pi. The pi is in the denominator because I don't want the pi to be there anymore. And I think I changed this on yours. What did I change b to?
Pi over 4.
Okay. All right, so let's do a together. So pi over 6. So I'm going to multiply by 180 over pi. So what happens to the pi's? They are gone. And then how many times does 6 go into 180? 30. 30 degrees is your answer. So try those next 3. It's been a long week.
Yeah.
Okay.
What? It's fine. Yeah.
Okay, so save yourselves a little time, reduce before you multiply. Okay? It makes life easier. Since I'm withholding your calculator. Okay. No, yeah, that's fine. Okay. 35. I'm hearing like numbers in the thousands, guys.
Well, I did have,
Reduce
I
first.
did have 3,340 at one point. Now it's only 390, so it's better.
Better.
It's just like.
All right, guys, let's go through these. All right, so times 180 over pi. So I know the pi's go away. How many times does 4 go into 180? So you can divide them both by 2, right? And then you have 2 and 90. Can't you then divide those both by 2 again? So like 45. So 4 goes into 180 45 times. And then what is 5 times 45? 225. Okay. All right, let's try C. Times 180 over pi. Pi's are gone. And then again, guys, don't do 5 times 180. You're making things much bigger than they need to be. How many times does 3 go into 180? 60. 5 times 60 seems easier. 300. Okay. Good. All right. D. Please do not multiply 13 times 180. You don't need to do that. How many times does 6 go into 180? 30. 13 times 30, just think 3 times 30 and add a 0. So what do we get? 390. Okay. All right. How are we doing? We're almost done with notes, guys. We just have coterminal. Okay, so to find a coterminal angle, you have the option of adding or subtracting. Sometimes I'll ask you to give me one positive and one negative coterminal angle. If I just say, give me any coterminal angle, I don't care if you add or subtract. It's up to you, okay? So you're going to add or subtract 360. That's not 360, or add or subtract 2 pi. Let's do A together. All right, that's got a pi in it, so what do you think I want to add? Okay, let's add 2 pi. And let's go ahead and practice the whole common denominator business. So common denominator would be 3. So I've got pi over 3 plus, what's the 2 pi going to become?
6 pi.
Good, 6 pi. So my answer to this one is 7 pi over 3. So that was your... It does. Absolutely. Yep. Yeah, you could give me negative 5 pi over 3. That would be great. Okay, then let's do letter C together. So I'm starting with 390. What do you want to do? Add or subtract? Yeah, subtracting seems easier this time. So minus 360. Okay. All right, you guys try B and D for me. to your neighbor. Do you agree? And you might not agree if one of you added and one of you subtracted, so that's okay. All right, guys, let's go through them. We'll settle some arguments here. Okay, negative 2 pi over 5. Do you want to add or subtract? Add? Sure, add 2 pi. So to add that, what does the 2 pi become? So I like 8 pi over 5. I would have also taken negative 12 pi over 5 if you subtracted. Okay. And guys, again, there are many more answers than that if you really like adding and subtracting. All right, negative 80. Did you add or subtract? You added. So plus 360. What'd you get? 280. Did anybody subtract? Okay. All right. Questions on it? Okay. Through 1.2. So we're going to do a